Now we begin Chapter 8, and we will talk about counting techniques. Now, Chapter 8 introduces, with more details, concepts related to permutation and combinations. At the beginning of the semester, we did talk a little bit about those two definitions. So let's just review them and introduce a few more details. Permutation deals with arrangement or ordering of objects from distinct objects. So more formally, arrangement of R objects from N distinct objects. As an example, let's say we are given 5 objects and we want to order or arrange 3 objects from these 5 distinct objects. We can name them as A, B, C, D, and E. And we could simply use blanks or boxes to represent the location or the position of each of the 3 elements or objects that we're going to permutate from those 5. So in the first space, we can put, for example, the letter A here. In the second space, we could put D, and the third space, we could put B. So that's one permutation. And we express permutations with tuples, right? This way, we indicate that the order of the elements is important. So in other words, ADB is different than ABD. So this is one permutation, and this is another permutation. We are permutating 3 objects from 5 distinct objects. Now, the question that we're going to answer in this section is how many are there? So here's one permutation, here's another permutation. I could have C, A, E. Well, if we look at the blanks or the boxes, we try to fill out the first slot, the first box, with one of the 5 objects that are available. So because we have 5, then there are 5 possibilities for the first slot. So we can simply indicate that the first one, there's 5 possibilities for the first. Then since we use one object here, that object cannot be repeated. So the second slot, we have 4 possibilities. Once we have one object here and one there, then we can't repeat any of those 2. So we have fewer possibilities. Therefore, for the third slot, we have 3 possibilities. Now there is a principle, it's called multiplicative principle, that says that we can multiply these numbers. 5 times 4 times 3, and that total will give us 60. The notation for permutation is this, P and R, and in this example we have P 5, 3, which is 60. So in general, we want to find the number of arrangements of R objects from N distinct objects. Again, we can use the slots, the blanks. This time we'll have R of them. For the first slot, we have R, well, we have N possibilities. That's the total number of objects. For the second slot, we have one less, N minus 1. For the third slot, N minus 2. Fourth slot, N minus 3. And notice that every time we move on to a new slot, it's the total number minus the previous slot, the number of previous slots. So here at 4, the total number is N, but we've used 3 objects, so it's N minus 3, so the previous 3. Here in the very last object, the very last slot, we'll have n, the total number n, minus the previous r minus 1 slot. So this is n minus r minus 1 possibilities for the very last slot. And again, according to the principle, the multiplication principle, we can find the number of permutations. So here's the number of permutations of n objects, of r objects taken from n objects is n times n minus 1 times n minus 2. And this keeps going until we reach this final number here, n minus r minus 1. Well, this number is really n minus r plus 1 because it's negative r, negative, negative 1. So let me go ahead and put that in there. Okay. Now, this form is not very, this formula is not very appealing the way it's written here. So here we do a little trick. We continue this expansion. Look that we have n times n minus 1, so we can continue these multiplications until we go down to 1, because every time we're subtracting 1. So for example, here the very next factor here would be n minus r, because it's 1 less than the previous one. So here the next one would be n minus r minus 1. And we keep doing that. Eventually, this will go down to times 2 times 1. Now, of course, we included these factors in there. We're changing the original expression. We don't want to do that. So we can go ahead and divide by the same expression, n minus r times n minus r minus 1 all the way to 2 times 1. Now, what is the reason we want to do that? Well, because this is simply the factorial. The top one is the factorial of n. The bottom one is the factorial of this number, n minus r. And the formula for permutation becomes much easier and simple.